Today I'll show you how to make this camera input for the racing game using the marker detector we built last time. We'll figure out this tilt using the marker centroids, and pulling back like this will activate the brake. Holding long enough switches to reverse as well. I'll also show you how to draw the augmented reality steering wheel so it looks like you're holding it. If you want to follow along and don't have the self-driving car / racing game code base, get it from GitHub and let's kick it up a notch.
Gonna code, debug, and have fun. Coding with Radu. Coding with Radu. Gonna prototype and design. Coding with Radu. Coding with Radu. Let's code now.
I've added the marker detector we implemented last time in the self-driving car racing game. And to control the car using the markers, we are going to need to implement the camera input. Now, I'm going to make a new version of the game for that control. And let's copy here race HTML, rename it to camera HTML so that we still have the way to control with the keys, and we also have that phone control from earlier. And now in camera HTML, we need to add a new canvas where we'll display our image coming from the camera. I'm just going to copy this camera canvas below and call it Iron Man canvas because we can make it look sci-fi. And let's give this a style. Inside of style CSS, I'm going to go at the bottom and let's make the position absolute. Otherwise, it's going to be pushed down by the rest of the game. And let's give it a margin on the top and on the left, like this. Let's open now camera HTML in a browser. And it should be here, but it's probably transparent. So if I right click on it and inspect, it does appear here like so. I'm not going to worry about styling it right now because this is going to be our image appearing there. So let's just see how to do that. In camera HTML, I'm going to go at the very bottom here, and we have to implement our camera controls in a new script tag. And they will work like this. We just initialize the camera controls on the Iron Man canvas and give these controls to my car. We're going to need to implement these camera controls using the marker detector. So let's copy here this one twice, and this will be the camera controls that we have to create. And let's remember to use the marker detector. Probably this one should be before the other one. And we implement the camera controls as a basic class. The constructor takes the canvas as the parameter, and let's store it as an attribute here. And let's get access also to this drawing context, like so. And this control, similar to the phone control, will need to figure out how to measure the tilt between our hands. So let's say that this is 0 at the moment. And we also need to figure out a way to go forward or in reverse. So I'm just going to assume at the moment that the car is going forward and reverse is going to be set to false. And let's initialize the marker detector here like so. We will use this to do our image processing. And to get the image, we need to access the navigator and get the user media from the media devices. So I did this already last time, and now I'm just going to go faster through this code, not explaining it as much. But basically, we set the raw data coming from these devices to a video element like so, and we tell the video to play. When the video has data, unloaded data, we are going to set the canvas size to the video size as well. First the width, and now the height. And then we loop. We need a loop here so that this image gets updated on every frame. I'm going to call loop like so. And if this fails for whatever reason, I'm going to catch the error and alert it so that the user knows about it. Now we just need this loop private method, and then we're good to go. I'm going to go here below the constructor, and loop is going to use this context to draw the image. It's going to draw this video, whatever the current frame is, from 0, 0, the top left corner, all the way to the canvas width and canvas height. And now we have to request animation frame so that this loop is going to call itself again and again and again. Now if you save and refresh, it's gonna look like that. We are here now on the camera, and the car is just going because we set this to forward and there's no control. Now our image here is really big, so let's style this nicer. In style CSS, I'm going to give this canvas width of maybe 300 pixels, and let's give it the border radius as well, 10 pixels, and let's make it transparent a bit so it's not so striking there. Save and refresh, and this is better, I think. But I don't want the car to crash like that, so let's also do the image processing and detect the markers there. So here, after we have drawn on the canvas, we can get the image data from this CTX like so. Again, from 0, 0 to the canvas width and canvas height, the full size of the canvas here. And now we call the marker detector. So let's get the result like so by detecting on this image data. And if there is a result, we will process these markers. I'm going to make a separate function for this. So process markers and pass this result as a parameter. And we'll implement this function up here just above the loop. So it's going to be a private method. And the result has that left marker and right marker information. I'm going to destructure it here so that we don't have to repeat result that all the time. And let's debug real quick to see if it works. So I'm going to begin a path, and let's set the fill style to red and do an arc. I'm going to draw a circle at the left marker location. So we're going to take the centroid of the left marker X and the centroid of the left marker Y. Let's just set the radius of 20, and I want a full circle, so 0 and 360 degrees or 2 pi radians. And let's fill. Now we're going to copy this for the right So let's make this one yellow. And this is going to be the right marker, right marker. Save and refresh. And now you're going to see that red and yellow dot on top of the markers. Let's calculate the tilt based on the angle they make. So here at the top, above this debugging section, we are going to say this tilt is the angle. So we use arctangent here between the difference on y, like this, and the difference on x. And now this should work. Let's save, refresh, and it did something, but my image is mirrored here. This is not great. Like you can see, it's mirrored by default. Here, before we draw the image, we will say this CTX save and then translate to the width. So we're moving to the right side, and now we scale by -1 horizontally. So scale -1 horizontally and nothing vertically, so it stays as 1. And after we draw the image here, we are going to restore. So like this. Now save and refresh. Okay. Oh, okay. Haha, it's working. It's working. Okay. Oh. Oh no, this sharp turn here. But this worked surprisingly well. I'm really amazed how good it felt. And I think the reason why I drove so well is because of the lag. This starts to be really processor intensive. And it doesn't have to be. So we can optimize this by using a smaller canvas here. Like we could try using maybe even a quarter of the size of the canvas when doing the processing. And this should feel much faster than before. Let's see. Okay. Oi. Yeah, much harder this time. Let's try again. Oh, okay. I preferred the slow version. Okay. You can see those circles there are really big now because that canvas is a quarter of the previous size. So the circles are much bigger relative to what we previously had. But this really feels real time now, and detecting those markers seems to work as well as before, maybe even a little bit better with less pixels. Yeah, let's make this look like a steering wheel. So plan was to use these wristbands and put them on my hand, but I think in this room they are so dark that they don't register. Has to do with the lighting here. So I'm gonna use these cloths instead. They are much more blue than my wristbands, and putting them on our hands like this is going to work. And let's begin by figuring out where the center of the wheel is and then drawing it like a circle, and remove this other debugging. It's not needed anymore. So here where we process the markers, I'm going to define the wheel center as the average location of the left marker centroid and the right marker centroid. And now the radius of the wheel is going to be the distance between the wheel center and left marker centroid, for example, or the right one, it doesn't matter. And now let's repurpose one of these debugger codes to draw here the wheel at this center, X and Y, and with that radius. We don't need the other one anymore. And let's see if this works. Save the file. I'm gonna put these things around my hands, refresh the page, and there's the wheel. I'm not focusing on driving now, I'm just trying to show you the wheel. It looks pretty good. I mean, it's how I imagine a wheel would look like in my hand. I'm really happy with it. But I would like to be behind my hands. So behind this thing, but in front of the rest of my body. So how do we do that? Well, we can take the blue pixels that have been recognized and just draw them on top of the wheel. For that, we need to go here after we process the markers, and let's loop through all of the image data items, and let's go 4 by 4 so that we go pixel by pixel. I'm going to set all the pixels to transparent. I find this easier to do in code. So all the alphas, we set them to 0. And now, after they are 0, we reactivate the alphas for the points in the left marker and the right marker. So for point of, and now I'm just going to combine here res dot left marker points and res dot right marker points. And in this loop, the index of this point is going to be the y value times the image data width plus the point x times 4. So we're doing essentially in reverse what we did in the marker detector. And this is now going to be the index we use to set the alpha. So plus 3, that's the alpha component, is going to be 255. And now with this new image data, you could put it on the context, but it's not going to work as you expect. Maybe, depends how familiar you are with this. So if we put the image data like this, starting at 0, 0, save and refresh, you see the image there, it doesn't exist. But if I'm gonna put this in front of the camera, you see just the cloth there. So I just made a way to turn myself invisible, pretty much. The thing is, when we put a new image data on top of our circle that we draw and the previous image, it replaces everything. Even if those are transparent pixels, the new things that we add there, they're going to overwrite the previous pixel values. So the trick here is to actually use a temporary canvas. So here we don't put this image data on this CTX, we put it on temp CTX. And then on this CTX, we draw the image coming from a temporary canvas that we need to define. So here at the top, I'm also going to add a temporary canvas, and we create this element like this. We don't need to add this to the document, just in memory is enough. And the context is this TMP canvas, the 2D context, like so. Now, it's important to have this the same size as our visible canvas. So I'm just going to take those values here, like so. And this should work. Let's save and refresh. And now you see that wheel is behind the cloth. Cool, isn't it? And of course, if you're going to have both wheels here, I know the car crashed, but I can't focus on it now. Then it looks like we are holding that wheel. And even the fingers here, they seem to be behind, but those cloths there are in front of the wheel. So this looks quite realistic, I think. You can get it more realistic, like what I had in the intro, but I'm not gonna go into that. Trick is I used gradients, and you can learn how to do that from that one tutorial I had about the torch effect. But I still want to teach you a way to adjust the threshold here. Like if the blue doesn't work for some reason and you want to adjust the threshold, maybe we do that by using the scroll wheel, like scrolling here on top of this small canvas. So let's go here at the end of the constructor, still inside the constructor, and add the wheel event listener to the canvas like so. And wait, I forgot this one. And depending on that, we will update the threshold. So we used this wheel event before when making the virtual world. What we do here is take minus the sign of the event delta y. When you scroll up, you get a negative value, and when you scroll down, you get a positive. So we want this to flip. And we only take the sign of that, not the actual value. Now, the marker detector doesn't have this update threshold method yet, so let's add it here real quick. And this is going to be a delta value, so we want to update the existing. And I'm just going to say the value is going to be the previous value plus this delta. But JavaScript types, this is going to be a string, and we want to convert it first into a number like this, and then add the delta. Now, if you save and refresh, and you hold it like this, and use the wheel, you probably have to use it quite a lot in both directions, because it's only changing one unit at a time, but you do have the control to make this as precise as you want. And I'm happy with many values here. Like I'm scrolling a lot and it seems to be just good. Could it be possible to recognize my wristbands? Yeah, kind of, I guess. Now the wheel is between them. It's okay, but it doesn't look great because they are so dark. They look so dark here, they're almost black. So if you do recognize them well, it's going to recognize everything else, like my hair is black and not great. So luckily, I have this alternative and it seems to work really well. But you don't want to adjust this threshold during playing. So I'm going to also show you how to store this new threshold value in the local storage. Let's set an item for the marker threshold and add here this threshold value like this. And when we initialize it here in the beginning, we check to see if there's a value there. So we try to get item marker threshold, and if it fails, if it's not there, then it's just going to use this 50. So now if you play with that threshold value and then refresh the page to restart the game, it's going to use the value that worked good the last time. Now, to do the braking and going in reverse, I want to be able to detect somehow that we are closer or further away from the camera. And the logic will be like this. We will have an initialization step when the countdown is happening while you see those numbers going down. There you have to be in the position that you are going forward. And it's going to memorize the size of the markers in that position. And then when you move backwards, the size of those markers will be smaller. So we detect that kind of change. It's easy, you'll see. So in the camera controls at the top here, let's say this initializing is set to true. And in our loop, I'm going to first check to see if we are still initializing. And I'm going to use the started global variable here, even though it's not that nice, but I don't want to complicate this any further. So if we are started, then we are done initializing. And in process markers, after we have this tilt here, for example, we are going to check if we are initializing. And if we are, then the expected size is going to be the left marker radius plus the right marker radius. You can use a bunch of things here, count the pixels, whatever, but I'm just going to add these and divide by 2 to have a kind of average. But it will work no matter what you do here, really. You just have to figure out the threshold afterwards. Now, this expected size is going to be 0 here in the beginning. And after we do this check, we measure to see what the current size is going to be. So that is the same formula as what we had previously, the average of the two in this case. And if this size is less than the expected size times some value. So here a value of maybe 85 worked good for me last time when I practiced this, but it was a different room and different configuration. So let's see what happens now. And in that case, then we are going to go backwards. So reverse set to true. And otherwise, we are going to set reverse to false and forward to true. And to debug to see if this really works, it's hard to tell by just looking at what the car is doing. So here, instead of just having red, I'm going to say if this dot forward, then use blue. Otherwise, show it in red. So now when going forward, we should see a blue wheel there, and red only when going backwards. Initializing now, and you can see when I'm pulling back, it's red and blue and red, and I crashed.